Welcome to the Hill Aerospace Museum. My name is Raylyn Embleton and I work in our education center. And we're so happy to have you guys back for our second week of our virtual STEM passport. A couple housekeeping things before we start. This week in the air park, or today in the air park from 1 to 3, me and my coworker Elizabeth will be out there passing out summer packets again and stamping your passports if you did, or not stamping, punching our passports if you did last week's activity and if you did this one as well. We'll be out there for 2 hours from 1 p.m. to 3 p.m. And you're welcome to walk around our air park. After you're done, enjoy the hot outside, the heat, and we'll be wearing masks. So this week is week 2 and we are talking about magnets today. Okay, so magnets are in everything. Right? We have magnets everywhere. You have magnets on your fridge to hold up your beautiful artwork that you put up there. We have magnets in our phones. We actually even have magnets in our cars. And then craziest of all, if you didn't already know this, our Earth is a magnet. And that magnet actually keeps us all alive. So right here, we have this beautiful illustration that shows that our Earth is a magnet. Okay, so we have our North Pole up here and our South Pole down here. And then this area right here, this is the Earth's magnetic field. This magnetic field is what keeps us alive. It actually blocks radiation from the sun. Without that, we would all probably be cooked on a day like today. So because our Earth is a magnet, we can also find our way around with compasses. But before we talk about compasses, we got to talk a little bit about the makeup of magnets, right? Okay, so I have a bunch of magnets right here. And these magnets have a North Pole side, this red side, and a South Pole, just like our Earth. Now, the thing about magnets is that if you have two sides that are the same, they repel. These guys don't want to touch. And if you have a side, if they're opposite, so a north and a south, they attract. Okay. So what I'm going to do is I have this awesome little device right here, and we are going to make these magnets repel and make them actually float. Crazy. So what I'm going to do is I'm going to put a magnet down, and if you're watching this video at home or live, you can comment or just talk along with me. When I put this magnet down and the north side is facing up, in order to make the magnet repel again, I want you guys to tell me what side should go face down next. North. Yeah, it's north. I heard it from the internet. I heard your brainwaves. Yep, it's north. It's repelling right here. So what side should go down next? South. Yeah, south. Okay, and then next is north, and then next is south, and then next is north. So all of these magnets are repelling. Okay, and I want you guys to notice the spaces between these magnets. Down here at the bottom, the spaces are a lot smaller than they are at the top, right? Why do you think that is? Because these magnets are weight, right? So if we take some of these magnets off the top, the gaps on the bottom get bigger because there's not as much weight pushing down. Okay, now you guys know, if I let my finger go, are these magnets going to stay together? No, because they want to repel, right? Because they're the same pole. Okay, so I'm going to let go. Oh, sometimes with this, you can get it to bounce off the top, which is super exciting. Okay, so now what I'm going to do is you guys have to tell me the opposite. So if I want this magnet to repel this one on bottom, what side goes next? South. And then what? Oh, I didn't give you a spoiler. Yeah, north goes next. Awesome. And then, oops. This time, south goes next. And then north goes next. And then south goes next. So that's how magnets work, right? They repel and attract, and that's how we use compasses, right? So again, we have our North Pole up here. So if we have a compass, it will point, the north will point toward the strongest magnet, okay? I'm going to move, this is a neodymium magnet. This is also a very strong magnet. So I'm going to put it over here because when you use a compass, you don't want a bunch of other magnets around because it's going to mess up your compass reading. So right here, I have a directional compass. And this is a compass you would use when you're backpacking or you're hiking. And north is that way. Okay, so you use this, but this isn't a good compass when you're like moving a lot, right? Like for walking around, it's fine. But when you're driving or maybe riding a boat or a plane, this is bad. This is hard to read, right? You'd probably get in a crash and that's not good. So there's actually a bunch of different type of compasses. This compass right here is called a mariner's compass. Okay, again, they use this on a boat so they can see which direction they're going. Now, the thing about finding your way on land is you don't just have to use a compass, right? There's landmarks that you can use, especially here in Utah. We're surrounded by mountains, right? And so we can use those mountains as natural landmarks to help us find our way. But when you're on a boat in the middle of the ocean, there's no landmarks, right? There's just sky and water. And so it's super important that you know which way you're going. Now, since we are an Air Force museum, I have right here an artifact. Okay, that's from one of our planes. It is actually from this F4 behind me. Okay, so this is called a standby compass. And as you're flying the plane, this, of course, plugs into the cockpit. And as you're going, this changes your reading based on which way your plane is pointing, right? It's super important to know exactly which direction you're going while you're flying, because if we're flying this F4 here and we're off by just even 1 degree and we're traveling, really fast, faster than a car, then by the time we get to our final destination, we could be hundreds of miles off course. So it's super important that pilots know exactly where they're going. This also would be plugged into a couple other instruments when you're flying or into a computer, which then can also help you understand which angle your plane is pointed at, like up, down, and the exact. And it can also help you know your altitude that you're flying at. And, a compass just helps to know where you're going when you're flying a plane, because like with a boat, up in the sky, you have limited landmarks. Okay, so going back to the fact that our Earth is a magnet, what is a magnet? Like, what materials can be a magnet? Do you guys know? Any of you at home? Take a second. Think about it. Okay, awesome. Hopefully you've thought about it. So if you didn't know, there are 3 naturally occurring magnets. Okay, we have iron, we have cobalt, and we have nickel. And when these occur naturally in nature, like in a rock, these are called lodestones. Okay, most of the time they're a little bit ferromagnetic, which means iron, and we'll talk about that in a second. And I gotta prove to you guys that I'm not just joking around. This is a very strong magnet. I already broke it earlier when I was rehearsing this video. This is a magnet, I promise. Now I just gotta get it off. At least I didn't break it. Awesome. Okay, and I mentioned that this rock was probably ferromagnetic, right? Okay, ferro means iron, which is really weird, right? Because when you look at the word iron, there's no F in there and there's no E in there, like its chemical signal. So if you've ever wondered about that, it's because the word for iron, before we had English, or before a lot of people spoke English, was ferrum in Latin. And so we took that Latin and we used the Latin name for iron in the periodic table, and that's why its element is Fe. So if you ever hear a material is ferromagnetic, that's what that means. It means it has a lot of iron in it. Okay, and so we have a lot of iron occurring in our world around us, right? Another thing that we need iron for is our bodies. You have to have iron to help your blood carry oxygen, which is important, right? If you don't have enough oxygen, you're going to pass out, which is a bad day. But our bodies don't naturally produce iron. Disclaimer, I am not saying go out and buy a buy of iron to eat it. Okay, don't do that. Just putting that out there. A lot of food has iron in it naturally. So leafy vegetables, leafy greens, which I should probably eat more of, have a lot of iron. Baked potatoes have iron, and I think red meat, or just meat in general, has iron in it. But my favorite that has iron in it is definitely cereal. I love cereal. So this moves into the more experiment part of our lesson for this week. So what you can do is at home, pick your favorite cereals, and we're gonna try and figure out which cereal has the most iron in it. Now at home, you're welcome to pick whatever types of cereal you want. We just picked 3 random ones at the store. And so we're gonna try and see which one has the most iron in it. Let me clean off all the dust from my iron, or from my lodestone here, so we don't have any magnetic dust messing this up. Okay, so if we just took this magnet, and again, this is a very strong magnet, but you try your magnets at home, and we try and, get these pieces of cereal to attach with the iron in it, it's not gonna work. Why do you think it doesn't work when the cereal is whole? Think about it. Because the iron is trapped inside the cereal, right? There's not a ton of iron in this, but you're not going to be able to get it because it's surrounded by a container, the rest of the cereal. So you're going to want to take your cereal and have some fun. And you're going to want to smash it. Okay, you're going to want to smash it up really, really fine. You could even use your blender or a food processor. We just used a mallet. But a blender works better. So what you're going to do with this ground up cereal is you're going to take a little piece of paper, or just your table, but this is a nice tablecloth. And we're going to put some on this piece of paper. Also, I would just like to point out we did get special permission from the museum director to have food in the gallery, because usually when you come to the museum, you're not allowed to have food in here, right? Just had to throw in those rules since I'm a teacher and everything. Okay, so here's our first type of cereal. Here is our second type of cereal. Move you, magnet. And you're going to want it pretty flat. You don't want a big pile of cereal because then it's hard to get to the little pieces. And here is our third type of cereal. It's a little more kid-friendly than the healthy digestive versions that we have, right? Because being healthy is important. We're going to spread those guys out. Okay, and if you do this experiment and you notice you're not picking up a lot, you can grind it down even farther. And then there's another option that we're going to talk about. Okay, so take your magnet and make sure it's all cleaned off of little magnet pieces so you guys can tell what this cereal is. Okay, so we're going to start on the left, or my left right here. Okay, so we're going to go over. You're going to want to get pretty close to the cereal, especially if you have kind of a weak magnet at home. Oh my gosh. Do you see all those little iron pieces in this cereal that we're picking up right now? That is so cool. Okay, at home, my challenge for you guys is please keep track of which one has the most, okay? Which cereal has the most. We'll call this one cereal number 1. Okay, we got to clean it off so we can move on to cereal number 2. Dun, dun, dun. Okay. This one isn't ground up as finely either. So we'll see. Look at that. Look at all that iron in that cereal. You guys be the judge. Drop a comment or, tell us later when we're in the air park. Do you think this one had more than the other one? Okay, I'm going to clean it up now. Okay. Now we're moving on to our third one. Now this one is more finely ground up than the other two, so just keep that in mind. Doesn't feel like we're getting as much. So at least this one's brightly colored so you guys can see it better. That one was weak sauce. It's not as much iron. Well, that was your challenge. Which one had the most iron? Which one had the least iron? So, that one didn't have very much iron, right? So, if you want to take this experiment a step further, right, you can test as many types of cereal as you want. You can go all scientific. Also, a good tip is when you're looking at the cereal in the grocery store, on the side of the cereal where it says all the nutritional facts that we usually don't pay attention to, it says how much iron is in the cereal. So you can check that against your results and see if, really the one that you had most cereal or the most iron pieces have the most iron in it. Or if your experiment was compromised and you just are going to have to buy more cereal. Oh no. But another way that you can get all these pieces to grind up even farther, okay, is to put some water in these bags. Oh, that one turned into a paste. Okay, so I'm going to grab my water bottle. I already put water in these two to hopefully help it dissolve a little bit. But I did not put water in this third one so you guys can see how much I put in. Okay, so we put about equal amounts of cereal in all 3 bags. Real scientific. And then we filled the bag about halfway-ish with water. Hold on, I gotta get all the water down in those little cracks and crevices. Okay, and this one's probably going to dissolve pretty quick. Okay, so I'm going to squeeze all the air out of my bag, put my water bottle on the ground, because you guys don't need to see my water bottle. Okay, and then what you do is you take your magnet, because now look, we have all those little pieces. We have our cereal paste over here. We're going to see if we get any more iron. Can you guys see that? Can you see the cereal following my magnet? That's crazy. Okay, let's hold it up a little bit. Is the cereal attracted to my magnet? It is a little bit. Oh my gosh, you guys are going to have to send me pictures and videos of all this at our email, education@aerospaceutah.org. So I can see how your experiment turned out and if it was cooler than mine. Because if it was cooler than mine, I'm going to be jealous. Okay, let's see. Oh, yeah. Oh my gosh, that's super cool. Okay, so that one did good. Ugh. This is a little disgusting. Okay, now we have this one, which is cereal number 2. I think, if you're following along at home, it had the most iron in it. So let's see how this does. These pieces are really big and didn't really want to dissolve very well. Oh, yeah. Do you see my little groupie? My little cereal groupies that are following my magnet? Oh, that's super cool. Hopefully I think my hand's out of the way. Oh, that's neat. Also, can you zoom in a little bit? Right here, you can see like little tiny flecks of iron once it dissolves enough. Super, super cool. And like I said, this iron is good for you, okay? I promise you're not just like, this is good for you. Helps you so you don't pass out, so you have blood and oxygen everywhere. Okay, we'll see how this turns out. I don't think I put enough water in there. I'm gonna pour some more water in just real quick. Mostly because it looks really gross and it's kind of grossing me out. Okay. Okay, let's see how this one does. Oh, well, this one's kind of hard to tell. Can you guys see anything moving? This type of cereal, if you get the same cereal that looks like this, I would definitely put this in a blender or food processor and not just use a mallet. Oh, it's working a little bit. At least I can see it. But like I said, you guys do this at home and send me pictures and videos so I can see how it's working for you. Okay. Well, hopefully you guys learned just a little bit about magnets, about how our Earth is a magnet, and about what compasses do for us and how that works with magnets, and about iron and why iron is important for your bodies. Okay, like I said at the beginning of the video, me and Elizabeth will be out in the air park from 1 to 3 p.m. today wearing masks. You guys are welcome to do so as well. And we will see you out there. Thank you guys so much for tuning in, and we'll see you next week at 11. Have a good day.